So, welcome to the OpenAI Gym micro course. So, if you're interested in in artificial intelligence and sharing your finding with other people, this is the course for you. So, the first thing, what is OpenAI Gym, and what will you learn in this course? So, OpenAI Gym is an API that allows you to separate your learning algorithms, your learning scripts, and the scripts that define the environment, the communication, the things that all the data that you have to send to the robot or to the entity that learns, the rewards and so on. You separate it. This has the main advantage is that you can design very different algorithms for the same environment. So, like the one we are seeing here with the Kabuki robot, or the other way around. So you can change the environment. Let's say you are learning with this robot here. And you're applying, let's say, a normal reinforcement learning algorithm, and you want to apply the same algorithm to a different environment, a totally different one. Like, for example, this one here, which is a hopper simulation, or this one here, which is the Miss Pac-Man game. So with this OpenAI Gym infrastructure, it allows you to change it to reuse your code very fast and easily. And not also that, but it allows you to share your findings with other people quite easily and compare it, because you can execute a code, a learning algorithm different from another person's, using the same environment, the same configuration for the environment. And especially if you use a cloud-based simulation, then you will use exactly the same environment. So you can compare very well if your algorithm is better than another algorithm of another person. So basically that's OpenAI Gym. So what will you learn? So if you go to this notebook here, there's more or less the explanation that I did. And what are you going to learn? So what you're going to learn is, one, create a script that learns, that applies some AI algorithm and makes a robot learn and communicates the actions that the learning algorithm thinks it has to make in the next step, and communicates it to an environment, any environment. This is the first thing you'll learn. The second thing you'll learn is to define in a script, in a Python script, this environment, different environments, and you will be able to apply it to your own environments. In this script, you will define the communication protocols that make the robot or the entity move. You'll also learn how to define the rewards that you will use to show him to the robot or the entity if it's learning correctly or incorrectly. And also you will define the observations, that the status of the environment, how is the environment in that moment, so that the learning algorithm learns and knows how the environment is and takes a decision of what's the next action to perform. You'll also learn how to plot the learning data, and at the end we'll do a tiny, very tiny project which will made you do all of this previously mentioned in a totally different environment. And you will see that actually there's not a lot of differences between this environment here, which is the using the TurtleBot robot with a laser, and in this environment, closed environment. So you'll see that it's not that different defining an environment for this one and for this one, which is a drone, a parrot drone in an open environment with different actions that can be performed. It's a flying robot, so it can go up and down, and also with totally different sensors, because you don't have lasers, but you have magnetic sensors, and you have altitude sensors and sonars, but it's totally different. But nevertheless, it's the script that configures the environment will be very similar for this one. So you'll see that in this micro project. So what do you have to know to make the most of this course? So you should have a middle level of Python knowledge, because all this course is based in Python code. Then you should have a basic understanding of how ROS works, especially topics. So if you don't, then I highly recommend you that before you do this course, you do in the same page, Robot Ignite Academy, you do the ROS basics in 5 days, which talks about, you learn all the basics needed for any ROS project. Then you have to know a bit of Unix shell commands and so on. And as for AI, you don't really need to know how AI algorithms work, especially reinforcement learning, but you'll get the most of the course if you do, because you'll know what you're doing, and you'll be able to do more tests and test your own algorithms that maybe you would like to test. So we highly recommend you to read this book, Reinforcement Learning, by Richard S. Sutton and Andrew G. Bartle. And finally, before we start, we would like to thank infinitely the OpenAI guys and the earlier robotic guys, because they've made this course possible. OpenAI, generating, of course, the OpenAI Gym infrastructure, and the early robotics company, because they made the Gazebo add-on for Gym, for OpenAI Gym, that makes possible that we use Gazebo Simulation for this. So thanks a lot for you, for these two companies. Thank you very much. And well, now let's get started with the course, right? So let's go. So the first thing we have to do is click next. Okay, so what are we going to do now? So in this first unit, what you are going to learn is how to execute a script that communicates with a robot and execute a learning algorithm of any kind. So because this course and all the courses that we have in Ignite are totally hands-on experience courses, let's try to execute this Python code first to see what happens. So do it yourself. So you go to the web shell and execute this command. And there we have it. So what you are seeing here is the robot trying to go through the maze without hitting the walls. If it hits the walls, then it resets the simulation. In this case, we will execute 10 episodes, but as you might know, to make this learn properly, you would need maybe 1,000, 2,000 episodes to make it turn all around the circuit, the simple maze. So here we will fast forward until it finishes. Okay, and we're back. So what you've seen is 10 episodes of this robot learning, and now we're gonna see what we executed really. So to see this, you can do anything that various things you can do. You can, for example, do a ROS edit and access this. Okay, so I can go here to a web shell and ROS edit any Python code that we have in a package, and we can see it here. I'm not a very huge fan of it, so but you can do this and take a look. You can also access directly through this path, but we have it here, so we'll take a look here to the code. So we're not going to explain in detail everything you're using here, especially the QLearn algorithm, which is a basic learning algorithm, one of the most basics. But what we are going to teach you here is the basic elements that you should know what they are doing, so that you can do your own simulation. You can do your own gym environment and use it and so on. So one of the first things we have here is in the main, you're, let's say, initializing this environment. We'll talk about it later in the next chapter, but this environment has all the data, all the configuration that states how the rewards work, what actions you have available, and which observations with which state of the simulation, how is the world, how is the lasers, how are the anything is in that moment. Okay, in OpenAI Gym we talk about observations, which means the observations are the state of the world, which could be the Miss Pac-Man world, could be this world here, any world. This is what we call observations. Okay, this is one part. Then we initialize this for what? For this monitor. So this monitor, this monitor method, what it does is initializes the monitoring class that records all the rewards and all the final scores of each episode, so that afterwards you can plot the evolution of the learning to see if your algorithm really works and the robot is learning. Okay, so and here we define where we want it to generate the files that we will use to then afterwards plot it. So then we initialize here the qlearn and so on. Here, what we're talking about here, this is more or less, you'll have to do more or less the same thing, but here we're defining the total number of episodes. In this case we did 10, and this is very important, how many steps we are going to perform. Maximum in this case is 500. This number, it's really important because it could give you an error if you don't define it properly. So for now, just bear in mind that this is the number of steps you want to take, and that it's very close related on how you define the environment. Okay, because there's a file which is the init file that we talked about a bit later, but there you initialize what's the maximum step limit, let's say. So it's very important that this number, you define it, that it's equal or higher, so more steps than the limit. Otherwise it will give you an error that it's a gym error, the module of gym, I mean. Okay, so this is the most important part, because here what we're doing is we're choosing the action based on the state, the observations. The state is the same thing in here, more or less. So for practical reasons, let's say it's more or less the same. So here what we're doing is choosing the action based on the qlearn. The qlearn chooses the action based on the state, sorry, and it gives you an action. Then you pass this action to this environment step, which will perform the action, and it will return you the observations, the reward, if it's done or not, if it's finished, the episode, and extra information, which in this case it's not returning anything. So then we do the observations, and we do the qlearn based on all this information, and that's quite it. We see if it's done or not, and if it's not done, then we go to the next one, and if it's done, then we break it because we've finished the episode. We'll see it in the next chapter, but basically if it's done, then it's because it has run into a wall in this case. So that's quite it. So exercise. So the first exercise that you have to do is, okay, let's do our own copy of this script so that we can modify it and do anything we want, an experiment. Okay, so what you have to do is execute these commands to copy these files to your desktop, let's say, to your region, your user workspace. Okay, so let's do it. That's one. Oh, sorry. That's one. This is another one. And the third one. And that's it. So here, you'll see that here you have now these 3 files. And we have a copy of that one. So what's the exercise? So I want you to do basically play around and try different things. So we can try to change the number of episodes, we can change the number of steps in each episode. So try it. So I recommend you that, for example, let's do the following. we can go here and change, for example, I don't know, we'll put 1 episode and we'll make it 2000 steps, for example. Then we execute this here. We're gonna execute it, for example, I'm gonna put it like this so we can see the output. And then I'm gonna execute my script. So Python my simple, okay, I'm not there, of course, so we have to go to Captain Workspace source. There we go. Now we can do it. My simple learning turtlebot Python. So it's executing the first one and finished in this case. Okay, you can execute it as many times as you want. So if we make the number of steps higher, then it will be, obviously the robot will be more time spent learning, basically, in each step, which allows it to finish the action, because if you give it 500 steps, maybe it won't have time to do all the turn, and it won't learn it. Okay, so that's basically what you have to do, so try it. Another thing that you can do is, as I said, is try another algorithm. For example, try the Sarsa algorithm. There's a script here which is an example, and it's basically more or less the same as the one we had before, but uses the Sarsa algorithm. Or make your own algorithm. So stop the video now, and when you finish doing all the examples, let's return. Okay, so one last thing before going to the next chapter is that in case for any reason that your Python script gets stuck, or you want to stop it, it won't stop if you do Ctrl+C. So if you go there and you do like that, and then you press Ctrl+C, it won't stop. Okay, but the robot will still be turning or moving because no one has told him what to do when it finishes. In this case, because the environment is defined that way. So how to solve this problem? This is hand-on experience. So we search for the process, and then we kill it, which would be this one, I think. And there you go. But yeah, that's what's happening. It's moving still. Why? Because no one told him to stop moving. So let's do a ROS topic, publish. In this case is in the command vel topic, and it's type geometry message twist, and then let's tell him to stop right now. And there you have it, stopped. If you didn't know what I did, please, I highly recommend you that you do the ROS Basics course before we continue. Okay, so let's continue to the next chapter. So this chapter talks about how to define the environment file. This is the most important file in OpenAI Gym API, because here you are defining really what's the action, what's going forward, what's going backwards, what's turning left, what's turning right. Because in a robot could be one thing, could be one kind of commands, and in another robot or in another totally different environment would be a thing totally different. So this is very important. It's also important because here you define the rewards. and the observations that you return in each step. So, first thing, let's have a look. So we have to go to the place where the Gym Gazebo Python module is defined. It's installed. So in your PC you'll have it. It's a very common place to have it here, but you can, maybe you've installed it in another place or locally, let's say in your workspace. It depends on how did you install it. So this Gym Gazebo package that you can download from early Git repository has these files. We won't talk about all of them, but we are going to talk about the basic ones. So the basic one here, the first one, is this init Python. So let's see what we have inside. So what we have inside here is the definition that we register each environment that we have. In this case, we have one here registered, which is the quadcopter version 0, which we will use in the last unit, in the last chapter of this course. Here we have another one, Maze Turtlebot Lighter. This is a default one. And here we have the Gazebo Circuit Turtlebot Lighter version 0, which is the one we used. If you remember, in Unit 1, we just did it. We imported, one of the first things we did is import this. Okay, and here we defined the name of its class, which is this one. And here we defined some extra parameters. The most important one is this one, time step limit. Why? Because this one avoids you to have this error here that we state here in the documentation. So the gym error, try to reset environment, which is not done. So in a nutshell, you need to put in the time step limits a number that it's the same or lower than the number of time steps that you're going to do in your learning script. Okay, very, very important. Otherwise, it will give you this error sometimes when you break before it should. Okay, so when you finish and it hasn't finished because you have defined it that way. So please bear this in mind. Okay, so let's dive into the file, the very important file here. So where is it? So it's in the envs directory. So we get out and we go to the envs. Here we have all the environments defined here. We have loads of them. The important one is this one here, we state here, the Gazebo Circuit Turtlebot Lighter, which we have it also here. So let's talk about a bit. Let's dive in. So first thing, what are we doing here? We're defining a class which is called like this, which is the same here. It's the Gazebo Circuit Turtlebot Lighter environment, Circuit Turtlebot Lighter environment. Okay, and inherits from this class and has some methods. And we are going to talk about them each one. So this one, it's an initializing method. So what it does is initialize all the services and all the topics that we use to communicate with ROS in this case, with Gazebo in this case. In your case, maybe it's another Gazebo simulation, or maybe it's a simulation in another simulator, or maybe it's a game. It doesn't matter. Here you define normally all the things that you need to communicate with your system. Then we're going to talk about the step method, which is the most important one. This one is the one that it's executed each step. You remember the 500 steps that we did maximum in the unit before this one? So here we're defining what we do in that step. So what we're doing in this case is unpause the physics of the simulator. Then we define the actions and say, okay, going forward means putting 0.3 in the linear x variable and not turning. Then going left is this values and going right are these values. Okay. If you don't know what we're talking about, go to the ROS basics, okay? So here we wait for the sensors. In this case, we are only waiting for the Kabuki laser scan. And when it's done, then we retrieve the data, which will give us how the environment is. So once we have it, then we pause the physics and then we process this data, the laser data. So now we go to this method here and we can see here that what we're doing is getting those data and new ranges, which is we are simplifying the data. And then here we define the minimum range that we define. And here in this method, we return two things. Discretized ranges, which is a version of data, of the laser data, but it's simplified to afterwards return it. And the most important variable here, it's done, because this one states if the episode is done, it's finished. The robot has finished that episode of learning. When does it finish? Tell me. Yeah. So here we are putting done equals true when the laser detects something that is below this minimum distance, which is normally the wall. It's the wall. Okay, so when we have this, we assign the rewards. In this case, if it's not done, so if we didn't run into a wall and we are going forward, we give 5 points. If we're not running into a wall but we're turning, then we only give 1 point. And if we did run into a wall, then it's minus 200 points. Okay, and finally we return the state, which remember is a simplified version of the lasers here, and then we return the reward and then the done variable. Then we go to this reset method, which is basically the method that it's called every time we initialize a new episode. So it's essentially the same. It's essentially the same. So, exercise. What I want you to do. So in this case, we're going to edit directly this file. Okay. What I want you to do. Well, play around a bit. Change some things. Change the rewards. Change the minimum distance, change, I don't know, generate another action. So we give some guidelines of what you have to do, each one of these. So this one is the most challenging one because you have to change two things. So you'll have to change the environment script, so this one, because you'll have to you have to define a new action here, and also you'll have to change this, action space. Because why? Because this one defines how many actions you have. So in this case you have three, sorry. So forward, left and right. So if you put one that it's going backwards, then you have to put here 4. Okay? And then you'll have to change the learning script, which we talked about in the previous unit. Okay? The previous chapter. Okay? So did you get stuck? Did you get into a loop? Did the robot get into a loop in some way? So please leave it in the comments, and because we would be delighted to know what happened. What are your adventures in this course, or any questions that you have till now, just leave it in the comments. Okay, so before we continue, just say that all this you can do it locally. You can do it in your PC with no internet connection. You just have to go to this website, Gym Gazebo Git, and also the gym docs are really good because they explain a bit how to use the basic gym examples. So we highly recommend them also. Okay, so pause the video, do the exercises, play around, and when you're finished, then continue with the video. Okay, so let's go to plotting the results. So the first thing to plot a result is obviously executing a learning episode, let's say, so that it generates those files that we talked about in the unit 1. So let's see those files, because we've done it now sometimes. So let's have a look. So I'm going to do it a bit bigger. There we go. Sorry. And we don't have it, so let's execute it again. So let's ROS run. Simple qlearn.py, and we execute it. So why don't we have them? Because the last one I did was I stopped it. I killed it. So it didn't have time to record new ones. So I'll fast forward this part, and when it's finished, I'll show you the results. Okay, and we're back. So now let's go again to see those files, if they were generated this time. So let's go here, and there we have them. So let's take a sneak peek inside one of them, just for fun. Okay, so it's really simple, right? We have timestamps and we have the rewards, basically. So what we're going to do is plot this based on, plot the each episode, which reward we got. So we see that here we got 248, then 8, then 88, then and so on. So we should see, not with 10 episodes, but with thousands. So we should see a tendency of getting higher and higher episode final scores each time. Okay, so how do we plot it? Here in the documentation we have this fantastic script, which what it does is plot the results. So let's have a look. There we go. Oh, but there's nothing. Or is there? So if you haven't used Ignite before, there's this tiny little button that opens the graphical interface. So there we have it. So we have all the rewards plotted in each episode. So episode 0, 1, 2, 3, 4, 2, 10. So, well, it's 0 to 9. So there's a tendency, well, there is, but I mean, with 10 episodes, you can't really say if it was learning really, we would need much more. So let's return here, and as we state here in the documentation, you have the example. Now we'll take a look, but we can also see that this script saves the image here. So we can use, for example, we can use EOG. Oh, sorry. Copy pasted the wrong one. There we go. Again, and with this is an image visualizer. You can save it in your workspace, so you can download it and do anything you want with it. So you have to save it in the source. So user catkin source, and you save it. There we go. And now we can close this, and now we can visualize it here. There we go. Now you can download it and do whatever you want with it. Just click and download. Yeah. Okay. So let's return to, there we go. So let's talk about the script. This is the script basically. It doesn't have anything totally bizarre and strange. So, and what I'm just going to explain here, that here you define where to save it, that's all. And here you're just telling it to plot it. Here there are many options, how you plot it and so on. We're not going to go inside it. Just use this script and it will plot your, and you can modify it any way you want, of course. So there's nothing more special about this. We have to talk about one thing, that although you won't be able to do it in this course, we think that it's important that you know it, because it's a very neat feature of OpenAI Gym. It's really neat. So you can upload your results to the OpenAI Gym webpage, and you can share them with any person there. You can leave instructions in form of a gist to tell them what to do and how to execute them. So here we leave documentation that states step by step how to do it. This you can do it locally or with any basic gym simulations, let's say, because it doesn't have, for the moment, for the time being, it doesn't have support for add-on environments, in this case the Gym Gazebo add-on, but we hope that in the future it will have, so we leave it here, and so that you can use it and know how to do it. Okay, so now we know how to define a learning script, we know how to define an environment setup script, and we know how to plot our results of how the robot or the system is learning. So now what? Well, you know all there is to know from the basics of OpenAI Gym. So now let's do a tiny project. So what are we doing here? So sorry. What we are doing here is using a totally different environment, which is a drone simulation, to make it work, to apply all the things that you've learned into a totally different environment. So the first thing you need in your environment, and so why are we doing this? We're doing this so that you know the procedure of how to apply it to your own simulations, to your own environments. That's why we're doing this. So the first thing we need to know is, okay, what we want it to learn. And what are the capabilities of this system? What are the sensors? What are the actions that it might be able to accomplish? Because, for example, this simulation doesn't have any lasers, but has other sensors. So we have to know which sensors are available and how to use them. And also define the actions. In this case, we're going to test it. So you can execute this script, which will activate the teleop control. So if we execute it, we can make the drone fly up and down. We can make it turn. Okay. We can make it stop and land again. Okay. So we know that this drone can turn around, go forward, go stop, and go up and down. So we have the actions that we could give it, that we could define in the environment. Next thing, okay, what's the objective? So in this case, let's put it a bit. There we go, much better. So in this environment, and the exercise that we propose here is this scenario, the following scenario. So this drone wants to learn how to fly as close as possible to the floor so that the enemy radar can't detect it. So that's the scenario. So we have to define the environment in a way that makes this drone learn to fly that way, that this behavior emerges from all the rules that we define. So what rules should we define? The basic one, the most obvious one is, okay, we won't let him go up, so we have to put a limit to the altitude that it can go to. So that's a limitation. And where would we put that limitation? Exactly, in the behavior, in the in the environment definition file. And what should it do? Exactly, make done, the variable done, true, because each episode has to finish, because it's wrong. It can't learn. It's wrong that he learns how to fly higher than certain altitude. Okay, that's one. So putting that, it's enough to learn? Of course not. You have to define other stuff like the actions. So which actions will it be able to? Obviously going up and down, that's obvious. And then go forward. And turning, yeah, why not? Turning left and right. So we have to define all those actions also. Yeah, and then the rewards. So what are we going to reward? Are we going to reward going up more than going forward? Or maybe we are going to reward negatively if it turns? Or how negative is to going to exceeding the altitude limit? All those questions you have to ask them to yourself, to your own, in your own simulation, and see what you have to define. Okay, so if you follow a bit here, we state the steps. So the first step we have to do is go to the init file. Okay, the first one is the init file here, which we're going to go right now. So we have to copy this path and go to our beloved web shell. There we go. We have it. Let's see. Okay, we have defined here already one for you. So what we want you to do is define another one. So a quadcopter version 1. So you just have to put another entry here which states quadcopter version 1 and uses your own class. So not the quadcopter environment, but the quadcopter environment 1, for example. And states the time step limit. The same, you can put any one you want, but bear in mind that it has to be lower than the one you'll put in the learning scripts. Okay. Okay. So we have it. Next step. Obviously, we have to define the environment. So let's go to environment. Whoops. Sorry. So we go to environment, and here we have the gazebo quadcopter. Again, you have to do your own version. We just state here an example, and you have to copy it and make your own version, of course. So here we define, this one is more or less the same, but here we have defined more actions, of course. Okay, so let's have a look in a place that we can see better. So here we have it, the quadcopter environment. We define the initialized variables, which is more or less the same. Whoops, sorry. Then we go here a bit, the step, which is exactly the same, just define more actions. So we have the up and down, and also the value is different, of course, because it's maybe for Kabuki 0.3 it's enough, for in this case for the drone 0.5 it's enough. Then here we wait for the data of the sensors that we need. In this case we're needing the altimeter, the magnetic sensor, and the EMO. Okay, yeah, and then we process this data, and based on that data we assigned a reward and the done variable. Okay, and then we assign an extra reward if the action was 1 or 2, so in this case going left or right, so we give extra points if it turns, to promote that it turns, and that's it. We define the state, in this case is this, and that's quite it. We have to define also the reset, don't forget about that, and then we have to define this process data, which we have here. So this is the most important part in this case, because here we get the data, we process it, and we see if it has finished the episode or not, and which reward we give it. Okay, so now it's your turn. So you have the code here. So let's see how it works. So we go back a bit. So we defined the init in the init file. We defined the environment. We registered the environment ID. Then we created a file that defines the environment. And the last one is the script that executes the learning algorithm. Okay, so let's execute it and see what happens. So let's go out and let's execute it. Whoops, sorry. So there we go. Too high. Now it smashed to the wall. Then there we go. There we go. It learned quite fast, you saw? Now he's learning. Now he tried it too much. Now there we go. As you see, you need more episodes to make it more robust, but you've seen that he has learned how to fly over it without going too high, based on EMU, based on the altitude, and based on the magnetic field. Okay? Okay, so your exercise. Do all these steps, do your own version called quadcopter version 1. Okay, so you have to write this script, the learning script. You can do it in your workspace. The environment, you have to define it in the place where all the environments are. So in this path here, let me see, here. Okay, as you wish. You can try to import other stuff, so you can have it all in your workspace as you wish. Okay, so what we recommend, so change the rewards, change the politics of how you assign these rewards, change when does it consider the episode to stop. Also, why don't you use other sensors, maybe the cameras? We would love to see people doing this project using the cameras. Maybe you can use the cameras to, I don't know, detect objects and say, okay, don't get too close to this object or that other. So try, be adventurous. Yeah. So any questions? Just write them in the comments down below. Okay, and that's quite it. So what to do next? So when you finish all this, you say, okay, I've done this, I've done a really awesome flying learning drone. What next? So it depends on what you want. So if you want to continue with this same simulation, with the Turtlebot simulation or the drone simulation, you have them available in the ROS Development Studio. So you just have to go to this web page and sign in, and you'll have all the simulations available. So you can use Gazebo, or you can use Weebots to continue your learning. So, but by the time we post this, we will have available this simulation. So don't worry. So the next step, you say, okay, I want to learn more about ROS. I want to execute the simulation, so you have them on ROS Development Studio. Okay, you can also download it from the Git. So Erle, have it here. You can download it for free, no problem, and you can do your tests and execute Gazebo Simulations also. You can also go to the gym docs and use the gym examples, which are very good. The two that I showed you in the intro, so the Hopper and Miss Pac-Man, are examples of this. So you can learn a lot here also. What about if you need more knowledge? Then if you need more knowledge, please go to Robot Ignite Academy, and there you can learn loads of stuff. You can learn ROS basics, you can learn navigation. So the same thing, you just have to go to Robot Ignite Academy and select the course that you want. And you can also go to the ROS Wiki, which is a very good source of information once you know a bit about ROS, and also gives you the tips of how to install it, of course. And finally, if you need some certification exam, don't hesitate to visit our webpage for ROS certification exams to take the basic level and the navigation level. And that's it. Thank you very much for staying till the end. And if you have any questions whatsoever, just ask them, and we would be delighted to know more about your projects and so on. So thank you very much, and see you in the next Ignite course, hopefully. Thank you.